Okay, we are entering to our next demo session. That is, I am inviting all our juniors friends to be involved in our next session on the topic of Valency. The team who is really going to present here is Faslana.E, Reshma Lukose, and Riya Johnson. Now, over to the team.
Good afternoon, everyone. Welcome to a new session of PR teaching. Our team consists of 3 members. I'm Riya Johnson.
I'm Faslana.E.
I am Reshma Lukose.
So we'll be dealing. Ma'am, participant screen sharing on cheyanam, ma'am. So we'll be dealing a topic in chemistry. Let's see what it is. On the screen, you can see a hydrogen atom and a helium atom. So other than the electronic configuration and structure, can you think of a difference between these two? Yes, there is a difference. We know that hydrogen can react with several other elements, while helium does not react with other elements. Have you ever thought why helium does not react while hydrogen reacts? So let's see what it is. Similar is the case with neon and argon. They also do not participate in chemical reactions much if we take their cases. So we have 2 groups. One is which reacts spontaneously and the other one is which do not react at all. The reason for this is called valency. Before moving on to valency, let's see what is electronic configuration. In this term, we can divide it into 2. That is, one is electronic, another one is configuration. Electronic stands for electrons and configuration stands for arrangement. So electronic configuration means the arrangement of electrons in the shells. That is what electronic configuration means. Now, if we see the case of hydrogen, we know that the first shell, the maximum number of electrons that can be accommodated is 2. But for the following shells, that is for second, third, fourth, and so on, the maximum number of electrons is 8. So the maximum number of electrons in first shell is 2 and our remaining it is 8. That is the basic of this thing. And this 8 electrons are called octet state. That is a stable state and it is derived from the word octa, which means 8. So the octet state is the stable state for the remaining shells. This can be compared to the case of a candy bag. You have a candy bag with you and if you are asked to take candy, you will grab the maximum amount of candies that you can grab. Like whatever your hand can grab, you will try to grab the maximum. So you might be thinking why I have put this illustration here. So this electronic configuration has something to do with this grabbing of chocolates. Just like the person tries to grab the maximum amount of chocolates, the shells also, they have a tendency to grab the maximum number of electrons around them. So we know that for the first shell, it is 2 electrons. So hydrogen has only 1 electron. So it needs 1 more electron to be stable, while helium has 2 electrons and hence it is stable. For the remaining shells, that is for the second shell, third shell and all, they require 8 electrons. So they'll always try to grab this 8 electrons around them. So we know that chlorine is not stable since it does not have 8 electrons around them. While argon and neon, which has 8 electrons in the outermost shell, are stable. That is, they have the maximum of 8 electrons around them. That is, outermost shell contains a maximum of 8 electrons. Then oxygen. We'll take the case of oxygen. We know that oxygen has 8 electrons. But does that mean all the 8 electrons will be in the first shell itself? No. According to the rule, the first shell can have only 2 electrons. So first 2 electrons will be filled in the first shell and the remaining 6 will be in the second shell. Right? So it means that is a first shell has maximum of 2 electrons. It has already filled it. And its electronic configuration can be given as 2, 6. From this, we can know that it lacks 2 electrons. That is, in order to become stable, it requires 2 more electrons. That is, it is not in a stable state right now. So how can it attain stability? That is what oxygen is thinking of. It can attain stability either by borrowing electron or sharing electron. So what factor decides, like if it has to share electron or borrow electron, otherwise give and take electron? That factor is called valency, and this valency and valence electrons are the reasons behind the formation of chemical compounds. So we'll see if that was an introduction to the topic valency. Now we'll see in detail what is valency. So I call upon Faslana for the same.
Yes. Now we are all, Riya introduced for us the topic as valency. So you all understood that what is valency. And Riya also introduced that the topic electronic configuration. So hope you all clear about that. Next, we are going to discuss more about valency. Can you see my screen?
Yes, Faslana. Yes.
Yes. Okay. Shall we start? What is valency? What do you mean by bond formation? When the bond formation takes place, can you give me the answer? It is for attaining the stable state. That is the answer. So for attaining the stable state, we have to, the elements undergoes in reaction. Here we shows that there is, in the first figure, there is a nucleus and a shell. There is only one shell and there is 2 electrons, like Riya already explained that. In the second figure, there is the nucleus and there is 2 or more shells. And in the first shell, there is only 2 electrons, and second shell, there is 8 electrons. So that is what is already explained by Riya. It is the electronic configuration, 8 electrons in the outermost shell, that is the octet state. Next, we are going to discuss that these atoms' names. The first one is helium, and the second one is neon, and the third one is argon. It has 3 shells, and the electronic configurations for each is helium for 2, and neon it is 2, 8, and argon it is 2, 8, 8. All it is in the stable state. That is the stable state. Then we are going to discuss about the bond formation. We can form the bond as give, take, or share electrons. Participation of electrons in the bond formation. Next, we are going to discuss that. Give or take electrons. In a bond formation, one of the element is either take or give the electrons. That is, we are called valency. So here comes the relevance of the term. Combining capacity of an element. It is valency. Now we are going to discuss more about it. In the first figure, there is only one shell, and the second one there is 3 shells, and it has the outermost shell 7 electrons, and in the first one there is only 1 electron. So like this, it forms a bond. The electron in the outermost shell with the other element. The capacity of an atom to give, accept, or share electrons to achieve the octet state. It is called valency. Then what will be for there is only one shell in an atom? Then the 2 electrons are shared by the 2 atoms and it forms stable state. Next, we are going to deal more about this. Here is the hydrogen atom. It has the nucleus and 1 atom in the outermost shell. It needs 1 electron for its stable state. So its valency is 1. So it needs 1 electron to obtain the stable state. Next one is oxygen. It has its electronic configuration is 2, 6. So there is 6 electrons in the outermost shell. So it is very difficult to donate these that it needs 2 electrons, and it is very difficult to donate these 6 electrons. So we consider here as it needs 2 electrons and its valency is 2. Next is magnesium. The electronic configuration of magnesium is 282. So in this case, here it is easy to donate these 2 electrons instead of need 6 electrons. It is very difficult to accept these 6 electrons from another atom. So it is very easy to donate the 2 electrons. So here comes the donation. Donating of electrons to obtain the stable state. Magnesium atom donates 2 electrons. So its valency is also 2, not 6. And the valency of hydrogen is 1 because it is accepting 1 electron. And magnesium, it donates 2 electrons, so its valency is 2. So we are going to discuss another case, sodium chloride, that is sodium and chlorine. In case of sodium, there is the electronic configuration is 281, and in case of chlorine, it is 287. So it is very easy to donate 1 electron to the chlorine. So the valency of sodium is 1 and chlorine is also 1 because it's accepting 1 electron and sodium is donating 1 electron. So this is the case of donation and acceptance. And it forms sodium chloride. We already know that it is the common salt. So the sodium electronic configuration of sodium becomes 28 and chlorine becomes 288. Both of the valency is 1. Next, we are going to discuss about water. In case of water, there is hydrogen and we already said that its valency is 1. It needs 1 electron. And in case of oxygen, its electronic configuration is 2, 6 and it needs 2 electrons. So there is only 1 electron can be shared with the oxygen. So here comes the sharing of electrons. So we need 1 more hydrogen atom for the sharing. So the 2 hydrogen atoms sharing 2 electrons with the oxygen atom and forms water. The formula is H2O. And the valency of hydrogen is 1 and oxygen is 2. This is all about valency. Now we are going to discuss what we have discussed today. I invite Reshma Lukose for the same.
Hi everyone. So now what Riya and Faslana detailed about what is valency and what are the peculiarities of valence electrons. So now we will look on what a quiz, and what from that we can know that how much you have learned. Okay, our topic is, we already know that valence electron. So question is, the electrons present in the outermost shell are called. There are 4 options: valence electrons, valency electrons, duplet electrons, and octet electrons. We have 20 seconds Faslana, can you answer the question?
I think it is valence electrons.
Yes. We will check what's the right answer.
Okay.
Yeah, yeah, it's correct. Faslana, very good. It's valence electrons. So moving to next question. Another question, second question is, how many valence electrons are in the oxygen atom? Our options are 6, 8, 10, 5. We have 20 seconds. And I would like to ask Riya to answer this question. Riya?
It is 6, Reshma.
Yeah, we will check what is the correct answer. Yes, it's correct. So moving to the next question. How many valence electrons are in neon atom? The options are 8, 6, 5, 7. There are 20 seconds. And Faslana, can you answer the question?
I think it is neon is in stable state, so it is 8.
Yeah, it's very good. Correct. We will look on that.
Okay.
Yeah, very good. Correct. So our final question. What is a valence electron? There are 4 options. Electrons with high reactivity, noble gases, an electron that has properties similar to a transition metal, or an electron in the highest occupied energy level of an atom. We have 20 seconds and okay. So Riya, can you answer this question?
Option D, an electron in the highest occupied energy level of an atom.
Very good. I think now you all are familiar with valence electrons. And there is another thing for us. So I'm doing another form of how we can find out the valence electrons. So first of all, this is an application called Wolfram Alpha. It's only what online platform. So we can go, you just type on the Google that valence shell calculator. We can find that what are the valence electrons on that atom. Now, okay, now magnesium. We have learned about magnesium. So I am writing magnesium. We can find out how many valence electrons are in magnesium. Yeah, 2 electrons. We know that thing. Okay, another example. What again? We can go to uranium. It's a what? Radioactive metal. So we will just for we can any metal. Sorry, any element we can find. So it also have 2 valence electrons. So hope you all understood. So for you, I'm giving you a follow-up activity. This is our follow-up your follow-up activity, that is make a still model showing electronic configuration of hydrogen atom, helium and oxygen. Also mention their valences. Hope you all are understood. Thank you.
That's all about
you.
today's session. Thank you and have a nice day.